Objective 8.3, Graphing Exponential Decay Functions. For Objective 8.3, we want to be able to sketch a graph of an exponential decay function and state the domain and the range of such a graph. So let's kind of go through the same process that we did with our exponential growth. Let's first take a look at things algebraically. Which of these four equations do you think represents an exponential growth function, and which ones represent exponential decay functions? Take a minute to think about it. Now hopefully you remember from our first objective that an exponential growth function is one in which our b is something greater than 1. So that means 1 would be something that we would consider to be exponential growth, and it also means that 3 would be something considered exponential growth because our base is 5. So if growth are bases that are greater than 1, then that probably leaves the bases that are less than 1 as decay. And that's exactly the case. So numbers 1 and numbers 3 represent exponential growth, while numbers 2 and numbers 4 represent exponential decay. And it all has to do with the fact that our b values were less than 1 but still greater than 0. So growth is represented by a b value that's greater than 1. Decay is represented by a b value between 0 and 1. Okay, so let's take a look at graphing an exponential decay function and then stating the domain and range of that function. So we can see here that we're dealing with decay because we have a b of 1/2. That's a number that's between 0 and 1. Now we want to be able to take this base to the exponent of -3, -2, -1, 0, 1, and 2. So go ahead and take a minute, pause the video, and fill in what you think the y values should be that would correspond with those x values. Come back when you're ready to check. Alright, so you have to think about how do we deal with fractions and negative exponents. For example, if I want to take, I want to take this 1/2 and I want it to go to the -3 power, then one way that I can do that is to take both the 1 and the 2 to the -3 power. Okay, but then each of those ends up being negative exponents. So in order to turn them positive, I actually need to flip them around. So I'm going to have 2 to the +3 power. Sorry, that's not looking much like a 3, is it? There we go. Over 1 to the +3 power. Okay, and that's going to end up just giving us an 8. Wow, 8 over 1, which is just 8. Okay, so a -3 for x ends up giving us an 8 for y. And then we can go through similar processes with -2 and -1 to end up with 4 and 2 for answers. 0 again, anytime we take 0 as an exponent of any base, we always get 1. And then when we put in the positive exponents, that's when we actually get fraction answers. Okay, so now that we have our table filled out, let's go ahead and plot the points. So again, take a moment to do that real quick. Pause the video if you need to, and then come back when you're ready to continue. All right, so if we plot the points, our points should end up looking like this. And so we can tell from the points that we're still going to get a curve like we did with exponential growth, but now instead of the curve starting out small and getting bigger, we start with a curve that actually starts out large and comes down and gets smaller as our x's get bigger. Okay, now the same question we asked with growth. Is this curve ever going to touch the x-axis? And the answer is still no. There is still no value of x that we can put in as an exponent that when we take 1/2 to that number, we are going to get an answer of 0. So we still have the x-axis as an asymptote. We still have a curve that is getting closer and closer and closer to that x-axis, but we're just coming at it from the other direction. So this is exponential decay because the amount that we start with is getting smaller and smaller and smaller as x gets bigger. So what then does that give us for domain? Well, if you notice here, the domain actually is not any different than what we had for exponential growth. We can still use any number for x. We still have arrows indicating that we could keep going in this direction, we could keep going in this direction. So our domain is still going to be all real numbers. And for range, this also does not change, since we are still looking at a curve that is completely above the x-axis. We are still looking at a range of y being greater than 0. So having a growth function compared to a decay function does not affect our domain and range. Domain and range for an exponential basic function is still a domain of all real numbers and a range of y being greater than 0. Okay, so now just like with our growth functions, we can use transformations to get new functions. So if we stick with our 1/2 to the x function as sort of the basic function, which is what we just drew, then what kind of effect is -3 going to have on this? Okay, well -3 is out here in the k spot. Oops, sorry. All right. So there's k. And that k is going to be a -3. So that means we take the graph that we had for the 1/2 to the x, that's what we just drew, and we take everything on that graph and we move it down 3 units because of the k being -1. Excuse me, -3. All right, so here's the graph that we just drew for 1/2 to the x. And now if we move everything down 3 units, that's going to put our points there so that we get a graph that looks like this. Okay, now what is the domain of this graph going to be? Well, again, there's not much that's going to restrict our domain in any of these problems. So our domain is still always going to be all real numbers. And if you remember, you can always shortcut that with the R that has the 2 vertical legs. Okay, so all real numbers is still our domain. What about the range? Did the range get affected by the -3? Well, the answer is yes, because -3 was a k value. K moves our graph up and down, and so that means that the asymptote that we had here at 0 also got moved up or down, in this case down 3 units. So now instead of y being greater than 0, we now have a y that has to be greater than a -3. Okay? And so there's our domain, all real numbers, and there's our range for this function. Y is greater than -3. Okay, let's take a look at another one. What if we want to graph y equals 1/2 to the x minus 5 power? Now what effect does our number have? Well, this time we have a, whoops, sorry guys. This time we have this minus 5 up here with the x, and that minus 5 being up in the exponent means that we're talking about an h value. And remember, the minus is part of the general form. So the actual h is a 5. So what does an h of 5 tell us? Well, if we know this is the regular 1/2 to the x graph, then an h value of 5 is going to move everything 5 units to the right. And so that's going to move our graph to this position. And in this position, what will our domain be? Well, our domain is still all real numbers. And what is our range going to be? Well, since we did not have any k value to move our graph up or down, our range is not going to be changed. So our domain is still all real numbers, and our range is still y greater than 0. Okay, let's take a look at one more that's got lots of things going on. Now we've got an a value, which is -1. We have a number up here, so we're going to have an h value, and in this case the h is also -1, because remember it's the opposite of what it looks like. And then we have this extra -2 out here at the end, so that's going to be a k value, and that k is going to be -2. Okay, so what does the a of -1 tell us? It tells us that our graph is going to have to reflect through the x-axis. The h of -1 tells us it's going to move to the left 1 unit. And the k of -2 tells us it's going to move down 2 units. So let's put all that together. Again, we're starting with what we know is the basic 1/2 to the x graph that we have been starting with on all of these. And remember, as I said in the growth objective, the first thing you usually want to do is take care of the reflection. So deal with the effect that a has first, which is to reflect your graph through your x-axis, and then deal with the h and the k. So the h moved it 1 to the left, and the k moves it 2 units down. So you end up here. Okay. What's the domain going to be for this? Again, it's still all real numbers. What about the range? What is the range for this new graph going to be? Well, because we had a k value of -2, that means we now have a new asymptote here at -2. But again, because of the fact that we reflected, our graph is not above the asymptote now, it's below the asymptote. So our range for this case is going to be the range, the y is going to be less than the -2, because now our graph is below our asymptote, not above it. Okay, so that should be enough information for you to be able to graph exponential decay functions. During class, you should be able to work on your 8.3 practice, and if there's any of these concepts that you're still having a little trouble with, make sure you ask questions. When you finish your practice, make sure you show it to me, Mrs. Gordon, so that I can check it off for you, and then you can continue working on with 8.4. We'll see you next class.